Dear students, so today we will talk about the first chapter of the big data, which is understanding the big data. So, as we have heard this buzzword that what is the big data and how it affects our daily life or how it like help us. So, there are three most important thing which is called three V's or sometimes we call as a five V's as an extension. So, three V's means like when the data has a high volume, high velocity and high veracity. So that kind of data we call as a big data. Okay, and sometimes we go for like variability and also the value. So that these are like extension for these three views. So we will see that which kind of data should be considered as a normal data and which data should be considered as a big data. So let's explore this chapter number 1 to see in depth concepts. Here in this first slide, you can see that we have three different kinds of data, which is in the form of the XML, which is like HTML kind of shape. Second one is a normal relational database, which is like Oracle data, or we have like MySQL or Microsoft Access or any databases available in the world. And third is called like images data or videos data. So these are different kinds of the data. So you can see there is a lot of variability or variety of the data. And when we have this kind of data in high volume, that is referred to be as a big data. What is a sample which is used for data analysis? So this is like, one of the sample which is used for normal data analysis. Like for data analytics, the symbol is little bit different with the different coloring scheme you can see here. You can notice inside this class. Uh, as I told you that value and complexity increases from descriptive to the prescriptive analytics. You can see here, initially, people were used to do like descriptive analysis just to describe the data to find the mean value, average value, like variances, standard deviations, and errors. That was just like the main purpose in the statistics. But now it went to the diagnostic analytics that why this phenomena is happening. There's been some hypotheses were developed on that one. Regressions, people went to that one. And then it leads to the predictive analytics when you predicted the concepts through certain like supervised and unsupervised algorithms like decision trees, or you apply some clustering techniques or reinforcement techniques. And the fourth most important thing is called prescriptive analytics, in which you go for optimization to increase the revenue or to go for the reduction of the cost, right? So cost cutting. So that is like more prescriptive analysis when you prescribe some organization or some individual to reduce the cost or to maximize the profit or to reduce the time consumption. So these are like more related to the prescriptive analysis. So as an analogy to, I will give you the example of like doctors prescribing some medicine after the diagnosing and predictive analysis. So if you see over here, as complexity is low, so the insight is low as well. We call it the hint side. Okay, when complexity is medium, so insight is increasing, and when complexity is higher, the foresight or the vision is more clear about the data. Here you can see the operational system we have it, which is pictured here. We have like query system or descriptive analytics tool to generate either reports or dashboards or picture, right? So here on the left hand side of the diagram you can see ERP, enterprise resource planning, CRM, like customer relationship management, and OLTP, online transaction processing. And these the data has been extracted with the using certain tools or certain like uh, grabbers, and then we push it to the reports or now specifically dashboard to have some KPIs. We use some techniques which is called drill down or roll up techniques to by using some question or some queries using the OLAP data. So online analytical data processing, that is the data which is stored for longer time, for 1 year or 10 years or 20 years in any organization or any store or in a hypermarket. So diagnostic analytics can result in data which is more suitable for performing drill down. You can dig down into the data, or roll up analysis as well. And then for predictive analytics, tools can provide user-friendly front-end interfaces, as I told you, like dashboard kind of things you can extract it from it. So usually the data is all pushed, the historical data is pushed into the OLAP. And then prescriptive analytics is more like, you involve like business rules, you involve with expert opinions from the different stakeholders you can put in, and it has in-depth analysis. So like a prescriptive analytics is the advanced form of the predictive analysis. BI comes here like business intelligence, which is used to improve the business application. It consolidates the data from understanding the data, cleaning the data, and then representing the data to the end user from the data warehousing. And it uses some queries as well, like SQL queries. You can use it, or if you have the big data, then you go for NoSQL queries. KPI is very most important thing, which is called key performance indicator, and which we represent to the dashboard, and it work as a central reference point for gauging the performance, that how our performance of organization is being going, and how can we improve it, or how can we accelerate our performance, either employee performance or revenue, etc. As I told you, there are five V's. So volume, velocity, variety, veracity, and value. So volume, big volume, velocity, speed. Like, every day we are getting not GBs, but you can say zettabytes of data, and variety of the data, like text data. We have image data, video data, audio data, and veracity means like authenticity of the data, and the value as well means like valuable data is most important, because sometimes we receive a garbage data. So how to take the, like for example 1 KB data from 1 GB data, so that is the valuable data. And then you can see like before we have like 5 billion DVDs, now equal to 2.5 exabytes, right? And then we have like terabytes, like 65,000 DVDs equal to 300 terabytes. So now organizations and user worldwide, they create over 2.5 of exabytes of data every day from social media, from companies, and all these things. As a point of comparison, the Library of Congress currently holds more than 300 terabytes of data. Now you can see social media, as I talked, 3,500, 350,000 tweets we have it, and we have then 300 hours of videos in YouTube, 171 million emails, and 330 gigabytes of the different data coming and generated from the jet engine in the form of the different sensors. So as I told you, that example of high variety of the data we include like structural data, textual data, video, audio, XML, JSON, and sensor data, and metadata. So these are the different examples you can see which is depicted in the picture. Data that has a high veracity, like high, and can be analyzed quickly, has more value to the business. So this is like graphically, the veracity concept has been elaborated. Example of human-generated data includes like social media, blogs, posts, emails, photo sharing, and messaging. These are like examples of like machine-generated data, like sensor data from GPS, from smart machines or meter or web server, or like industrial data, telemetry data, smart meter data, and from aeroplanes, and from different like sensor we use nowadays now, because we know the new technology IoT comes, so everywhere there is a sensor. The symbol which is used for structured data storage is in tabular form, two-dimensional X and Y, Z, column and rows, or we call tuples and attributes. Then we have videos and image files and audios files. These are the representation and how we have this one. And these are the particular example of unstructured data. Semi-structured, which is not like fully unstructured or not like fully structured. It comes like sensorless data, or JSON data, or the XML data. So XML structure is same like the structure of HTML, while JSON they use like curly bracket and square brackets. Metadata, how can we represent the metadata in the form of the shape? So it's just like a sticky note kind of thing is pasted over the 01 file and with a clip. So this is the end of the first chapter, and in the upcoming chapter we will have some more details about the big data, what are the storage problems we have it, and what are the processing needs for the big data using the cluster. So thank you very much and see you in the next video.